Hi, my name is Miłosz and I live in Poland. But for most of the time, I'll be just a set of hands. I'm here to talk to you about animation. But what actually is animation? Animation is an art of making ordinary objects alive, like this rock. Go, shoot, shoot. That's better. But our rock is quite boring now. But if we put a little bit of magic into it, it's alive. That's the power of animation. You've probably seen a lot of animation, like hand-drawn animation maybe, or 3D animation, computer animation. Maybe you've seen some stop-motion animation, like pixelation in this case. We even have a solid animation. But how to actually do that? That's what we are going to find out today. In reality, animation is just a trick. Have you ever seen a movie frame by frame? So just an ordinary sequence. But if you take a look frame by frame, you can see those are just images. So the job of an animator is to do the same thing but in reverse. By creating static images, but very particular ones, we create motion. So let's experiment now. Let's try to animate our rock. When you see my hand leaving the screen, it means I'm taking a picture. And every time I take a picture, another ghost image of previous position of my rock appears. It's called onion skin, and it's a basic tool of every animator. It shows you previous shape or location of your objects, and it allows you to control your animation precisely. So now you can see our animation. Quite nice, right? Let's try with something more difficult. I'll position the stone in the beginning of the frame and I'll move it just a little bit every frame. So every picture I'm taking, I'm moving this rock a little bit to the left. Here you go. I'm trying to maintain the same distance and I'm taking pictures. So every ghost, or as we animators say, onion skin you see, it means I've taken another picture. A few more. One more. And we're done. And how our animation will look like? It will be just moving from right to left. So we could animate a moving car like this, or sliding object. What is important here? That the speed is constant. Alright, let's try something else. The same starting position. What's different? The distance. So now I'm moving the rock very slightly every frame. As you can see, the distances are the same. Mostly, I'm trying. So what will be the result of that? Movement from right to left, of course, but what about speed? It should be much slower than before. Because now it takes more time to move if you move very slightly. So if you walk slowly, you will need more time to reach your destination, right? When if you run, you don't need as much time. So we have a very slow movement now. So now you should be able to tell the difference between animating slow or fast objects. So let's see the comparison. I'll take 2 rocks. But first, let me show you something. This is me. I'm walking, jogging and running. So you can see on the top I'm walking, in the middle I'm jogging, and in the bottom frame I'm running. And what's different here? Of course, it takes more or less time depending on the speed. But what's the most important thing or observation for animator? The distance. So take a look now. Can you see differences in distances? Look at my head. So at the top it's moving only very slightly, in the middle a bit more, and at the bottom it moves a lot. And you can see the difference in speed when we play the sequence. Interesting, right? Back to our rocks. I'll move upper one more and the one on the bottom just a bit less. And of course I'll do that every frame and then take a picture. So as you can see, animation takes a lot of time, so you have to be patient. So we're taking many pictures now. So you should already know which one is going to be moving faster. What do you think? Yeah, you're right. The upper one will be faster, much faster. Alright, I think that's enough. Let's see that in motion. Can you see the difference? It should be obvious now. So what do we need to remember? Moving little, slow, moving more, faster. Alright, bye rocks. Let's try something else. If we already know that the distance means the speed, so why not trying to vary the speed? If we think about a moving car, for example, car can accelerate or decelerate. So if we try to move this car to the left, but every time we move it just a bit less than before, than previously, what should we see? So if the distance changes, if it's getting less and less or smaller and smaller, our car should slow down, should stop. So you can always mix different speeds. And the result of that is a dynamic movement. We should see now the car going from right to left and stopping smoothly. Everything needs to stop smoothly. If we stop suddenly, if we do, we crash into something. Or if we stop very suddenly, we fall over. So if we can slow down, or should we say decelerate, we can also accelerate. Start by moving very slightly or gently, and then add more and more every frame. So if the car stops and then wants to go the other way, we can accelerate the car and move quite fast at the end of our shot. Let's see how it looks in real time as soon as we finish our last frame. So 2 more frames. And we're done. So we have our fast moving car. Interesting, right? So let me show you an example. What I'm doing here is just launching the ball, throwing the ball upwards, and there's nothing interesting in that. But if we take a look at the ball through an animator's eye, we'll see that there is a difference between positions of the ball in every frame. So you can see the pattern now. So we see deceleration. And it happens again the other way. Let's try to take this knowledge and put it into animation. What I'm going to draw now, it's called motion sketch, and every animator uses them. So I'm sketching the distances of our object. So I'm moving more, as you can see, so there will be some acceleration probably, right? So if we're starting slowly and then moving more and more, we should see an object accelerating. But if we go back from 1, 2, 3, 4, 5, 6 to 7, 8, 9, 10, 11, so if we repeat those same positions going the other way, we should see deceleration, right? So if the object at first will accelerate and then decelerate, what should we see? Can you imagine? Yes, that's our bouncing ball. And a bouncing ball is something very, very interesting. Every animator has to animate a bouncing ball at least once. It's one of the basics. So let's try again. Do the same thing, but without a motion sketch. First, we need to accelerate and then decelerate. So what we're trying to do is to get back to the first position that we started with. So that's our bouncing ball. Very good. So the last thing I want you to try is to animate a car going from left to right, but the car already moves fast. So the distances are large at the beginning, but then it smoothly decelerates and stops, but while stopping, it also tilts upwards. The same thing happens with your body in a tram or a bus when it stops suddenly. So we will try to visualize that force acting on our car. We will not only make the distances smaller and smaller to lose the momentum, but we will also start to rotate the car upwards. But the rotation will follow the same rule. So we will start more because the force is bigger at the beginning. And then we will ease that out, making those rotations smaller and smaller. Alright, that's it for today. Try to have fun and experiment with animation. Try to animate bouncing ball. Try to animate car accelerating or decelerating. And if you're confident, try to animate the car decelerating and also tilting. Thank you and good luck.